Hello, and today's learning target is I can solve a system of equations by elimination. Today we are going to continue studying solving a system of linear equations. However, we are going to learn a new method of solving, and this will be our third method that we've learned. We were able to solve by graphing using the substitution method, and now we'll solve by using what's called the elimination method. So the goal of this method is to eliminate one of the variables by adding or subtracting the two equations together. So we want to eliminate or get rid of one of the variables, solve for the other variable, be able to plug it back in, and then solve for that last remaining variable. Let's take a look at an example. Do you see in our two equations that I have a negative 4y and a positive 4y? So if I were to add those two together, those y variables would cancel out. So that's what we are going to do. So I see that they have opposite signs, right, of the negative 4y and positive 4y. So I'll go ahead and add the two equations together. When I add them together, we'll see that the y variables will be eliminated or cancel out. Negative 4x plus 6x, so I'll add together my x variables because those are like terms and everything is already lined up nicely, so that's really good. And that gives me 2x. My y's cancel out, negative 4y plus 4y, so I'll just cross those out, equals, and 4 plus negative 8 is negative 4. Now I can solve for x, so I'll divide by 2 and get x equals 2. So I have half of the system solved, but now I need to figure out the y-coordinate. So I'm going to take that answer right here, x equals 2, and plug it back into one of the two equations, whichever one looks easier that I started with, and then I'll solve for y. So let's go ahead and plug that in the second equation. Looks like maybe a few less negatives to deal with. So 6 times 2 plus 4y equals negative 8. And I'll go ahead and solve for y. 6 times 2 is 12, plus 4y equals negative 8. Subtract 12. I might run out of space here. So I get 4y equals, and then negative 8 minus 12 is negative 20. Divide by 4, and y equals negative 5. So my final answer, written again as an ordered pair, because that's how we write our final answers for systems, right? The ordered pair that would work for both equations would be 2, negative 5. And again, I could check my answer by plugging 2 in for x, negative 5 in for y into both of the equations, and it would work for both of those equations. All right, let's move on to the next example here. Okay, so as we look at these next two equations, I see a 4x and a negative 4x, right? So those are the same, they have the same number coefficient in front of the variable, just different signs. So that's great to use the elimination method. So what we can do is, since they're opposite signs, if we add them together, they'll cancel out, right? Because 4x plus negative 4x is 0x, it gets eliminated. 9y minus 3y is 6y. Negative 14 plus 2 is negative 12. Then I'll divide by 6 and get y equals negative 2. Now I have my y-coordinate, but now I have to plug that back in to find my x-coordinate. So 4x, maybe I'll go right over here to the side so I'll have more space. 4x plus 9 times negative 2 equals negative 14, so I plugged it in that top equation. Get 4x minus 18 equals negative 14. Add 18 to both sides. 4x equals 4. Solve for x by dividing by 4. So we get x equals 1. So to put it together, for my final answer written as an ordered pair is 1, comma, negative 2. All right, let's look at the next example here. X plus y equals 7. Negative 3x plus y equals negative 5. So I see here that I have 1y and 1y. So if they're both positive, in order to get them, get the y's eliminated, I would subtract. So I'm going to subtract this entire second equation. So I have x minus negative 3x. that it will give me chop chop a plus, so that's 4x. Now I have y minus y, which means those cancel out. Then I have 7 minus negative 5, and 7 minus negative 5, chop chop is really plus, equals 12. So it's really important that you're careful with the signs, especially when we subtract, to make sure that you subtract every term. So if I want to solve for x, I'll divide by 4 and get x equals 3. But again, that's only half of my answer, so I have to plug that back in. So I'll go ahead and plug that into the top equation and get 3 plus y equals 7, minus 3 from both sides, and get y equals 4. So my final answer written as an ordered pair would be 3, 4. Okay, let's move on to the next example. So I have 4x plus 2y equals 16, and 4x plus 6y equals 8. So I'm going to eliminate the x's, so I'll subtract, and then 4x minus 4x is 0x, 2y minus 6y is negative 4y, and 16 minus 8 is 8. I'll divide by negative 4 and get y equals negative 2. But again, that's only half of my answer. I need to plug that back in to find my x-coordinate. So I'll plug that into the top equation and get 4x plus 2 times negative 2 equals 16. So 4x minus 4 equals 16. We'll add 4. Divide by 4. So x equals 5. So I'll go ahead and write my answer as an ordered pair, 5, negative 2. All right, let's move on to the next example. Okay, I'm going to zoom in on this first example here. So my two equations are 20x plus 7y equals negative 29. And then negative 10x minus 5y equals 25. So I don't see the same coefficient or the opposite signs of the coefficients in front of any of these variables that would allow me to eliminate them just by either adding or subtracting. So what I'm going to need to do is I'm going to need to manipulate or change one of the equations so that I see the same coefficient in front of a variable that would allow me to eliminate one of the variables. So as you see, 20x and 10x just differ by that 20 is times 2 to the 10. But the 7y and the 5y, I would have to change both of the equations in order for them to turn into the same y, which would be like 35y. So I would have to change or manipulate both equations, and that requires a little bit more work, which let's just do the least amount of steps possible. So let's change the negative 10 into the 20 or to a negative 20 so that they have the same coefficient. So what I'm going to do is I'm going to take this whole equation and multiply it by 2 so that it turns into, the top equation stays the same, but the bottom equation, negative 10x times 2 is negative 20x, negative 5y times 2 is minus 10y, and 25 times 2 is 50. Now I can use these equations and eliminate the x variable. So now what I can do is if I add together the two equations, the x's will cancel out. 7 plus negative 10y is negative 3y, and negative 29 plus 50 is 21. If I divide by negative 3, I get y equals negative 7. But now I have to plug that back into one of the equations, so I'll go ahead and do that to the original equation before I changed it, the negative 10x equation. So I'll say negative 10x, and again, it doesn't matter which equation I plug it into, minus 5 times negative 7 equals 25. So I have negative 10x plus 35 equals 25, subtract 35. Again, I'm just solving for x, and I get x equals 1. So to put my answer as an ordered pair, I get 1, negative 7. Okay, let's move on to the next example. 6x plus y equals negative 20, and negative 10x plus 6y equals 18. Let's change the first equation with that 1y to change into to be a 6y. So all we would have to do is multiply the top equation by, let's multiply that by negative 6, and then we'll be able to add the equations, and this negative 6y and positive 6y will cancel out. So what that turns into is negative 36x minus 6y equals, and then negative 20 times negative 6 is 120. And then my negative 10x plus 6y equals 18 doesn't change. We'll go ahead and add these two equations. So negative 36 plus negative 10 is negative 46. Negative 6y plus 6y cancels out, and 120 plus 18 is 138. We'll divide by a negative 46. And 138 divided by negative 46 is negative 3. So now I'll plug that back into, let's just do the original top equation here before we changed it. So 6 times negative 3 plus y equals negative 20, and get negative 18 plus y equals negative 20. We'll add 18 and get y equals negative 2. So my final answer written as an ordered pair would be negative 3, negative 2. All right, please feel free to solve this last system of equations. I am going to go on to the last page of notes and do a couple of the examples on that slide. Let's look at this middle example to start with. So I have 16x minus 12y equals 8, and negative 4x plus 3y equals negative 2. Now I want to change one of the variables into, make it the same number as the other, but if you notice with the top equation, I have 16x, the bottom equation, negative 4x, so that's times 4. Then I have negative 12y and 3y, that's also times 4. So what you're going to see here is there's going to be more than one variable eliminated. So let's multiply the second equation by 4. And I get negative 16x plus 12y equals negative 8. And the top equation is still 16x minus 12y equals 8. So now I'll go ahead and add the two equations, and 16x plus negative 16x cancels out. Negative 12y plus 12y cancels out. So I essentially get 0 equals 8 plus negative 8 is 0, and 0 equals 0. And so this answer means that I have infinitely many solutions. Okay, and let's take a look here at this last example on this page, and we'll skip that first example. So I see I have negative 16x plus 20y equals negative 4, and negative 8x plus 10y equals negative 4. So with this example, I can see, I have a negative 8x, change that into the negative 16x, or the 10 into the 20 for the y's. And as you notice, if I multiply 8 or 10 by 2, I get the other equations numbers. So I get negative 16 or I get 20. So this might be another unique example or unique answer with this example. So I'm going to, instead of first, adding, I am going to multiply the second equation by negative 2. So the top equation stays the same. The bottom equation will change to a 16x minus 20y equals 8. And I'll go ahead and I'll add the 2. So my negative 16x plus 16x cancels out. My 20y plus negative 20y cancels out. So I'm left with 0 equals negative 4 plus 8 is 4. And 0 cannot equal 4. So with this example, this means we have parallel lines. So here we actually have no solution. 0 does not equal 4. Thanks for watching the video on solving by using the elimination method with a system of equations. Have a great day. Bye-bye.